Now, um, system services basically is a system program that provides a convenient environment for program development and execution. So there are a lot of categories where it would help file manipulation, information programming, program loading, communications, and etc. Right. So I'm gonna skip some of this. Please read the slides. But I would like to go on to talking about linkers and loaders, right? So linkers are basically a source code compiled into object files designed to be loaded into a physical memory location. They are basically help in modern general purpose systems. They don't really link the libraries into executable, but they are rather dynamically linked libraries. In Windows, we call it DLL, right? So um, so if you see a bunch of DLL on your Windows machine, these are actually quite important and they provide the linkages to links and loaders. So if you look into this, for example, a source code goes into a compiler, it creates an object files, and it will be linked to other object files that it requires, all the system calls, libraries, etc., and create an executable. So it's not like any program is basically independent. A linker is required to link all of the important components, and then it will be a particular program gets created and gets run. For dynamically linked objects, it will be loaded, and then all the dynamic link libraries are loaded to basically run the program. Okay, so let's me go through again, forward to some of the implementation uh, on kernel structures, right? The operating system structure basically has a couple ones in historically we had MS DOS, we had some Unix, we had some layered one and microkernel approach. Now, the original Unix is what we call a monolithic structure. It is consists of it can be separated into parts, basically system programs and the kernel. The kernel itself consists of everything below the system call interface and above the physical hardware. So if you refer to the picture on the structure of the operating system, it's right in the middle where the operating system is. Basically, it will provide all the file system, CPU, scheduling, memory management, and etc. So it is considered one of the more important parts, right? So you can see here that the kernel is right in the middle. There will be a shell that's provide interface, and there'll be user applications, right? So almost a lot of all operating system has a very specific kernel. Windows has it, Linux has it, FreeBSD has it, and Mac OS has it. And monolithic kernel basically works this way. We have system calls, we have file system, there's device driver and the hardware particularly, and everything is managed inside the kernel itself, right? So you can see the layers approach here. uh, um, so it's very monolithic in this sense, right? So next we'll go to a layered approach. The operating system is divided by number of layers here, uh, and okay, right. And they would, if you look into this picture here, right, the microkernel sits here, and inside the microkernel we have all kinds of um, uh, services that the operating system provides, basically to manage the CPU, manage the memory, and etc. Right? There are some other approach. So keep in mind the difference between monolithic structure and layered approach microkernels, and hybrid systems, right? So hybrid system is a bit weird. The Mac OS X is a hybrid. It's layered. They have an Aqua UI plus a Cocoa programming environment. is it has a kernel, microkernel, and a BSD Unix part, which makes it pretty much a combination of both. And you can see part of the macrokernel and microkernel inside it to provide basically the Darwin operating system based on iOS. Android has a similar structure to Unix. Basically, Linux is a modified version of the Linux kernel. Alright, so let's stop there and we'll come back to this slide later.